Good morning, good afternoon, good evening, everyone. This is our final topic of the year, believe it or not. Okay, we're going to do inverses with the unit circle today. And really, when we use the unit circle, remember that we're really going to be using a lot of special right triangles. So I'm going to add that up here to the topic so you guys remember how important these are. Special right triangles. Okay, next week is going to be our trig test. That will be on Thursday. So we'll spend the beginning of the week doing some review. We'll have a study session on Wednesday to get all your questions answered. And that test will be the last grade of the year for you guys. The last week of the school year, we will go over our summer packet for pre-calc. So we'll get going on that and get working on that. So it'll take some of that work away from you guys for the summer. All right. As always, email me if you have any questions. Okay, let's dig into this. So we're going to start with a little review, which is good, because we need to talk about what inverse functions are. So as you look at this triangle, we notice that we know two sides, but we don't know the angle. This is when we use inverse trig functions, when we don't know the angle. So remember, all you guys are going to do is set up an equation for this. And you have to figure out which trig function we can use. So as we look at this angle, we say, okay, across from this angle, the opposite side is 7. Next to this angle, the adjacent side is 5. And then I ask myself, well, which trig function compares the opposite side with the adjacent side? And I'll pause while you guys think about that. Hopefully you're writing this down right now. That is our tangent function. So we would set up an equation like this. The tangent of theta equals 7 over 5. All right. Now, in order to do this, we use our inverse trig function. So this is where you're going to need your calculator. If you don't have it, please get it out. Notice up here the directions, it says round. When we say round to the nearest tenth, that means you're going to use your calculator. If it says exact, it means that you are not going to use your calculator. You're going to use your special right triangles or your unit circle. So now once we get this equation set up, all we have to do is take the inverse tangent of both sides. And what happens is we get theta by itself, and we get theta, or our angle, equals the inverse tangent of 7 over 5. So that's what we're going to put in our calculator now. We have second tan 7 divided by 5. Make sure that you are in degree mode. And we get theta equals, we're going to round that to the nearest tenth, 54.46. Oh, we want the tenth. Let's go back and make that to the 10th then. 54.5 degrees. There we go. All right. Now, here we have the triangle, so you guys can get that visual. Here we just have the equation. Remember, if you have the equation, all you're doing is you're doing your inverse cosine function. So inverse cosine of 0.59 means what angle would give us that ratio of side lengths. So again, put that in your calculator, hit second cosine, 0.59, and there we go. Theta equals 53.8 degrees. Okay. All right, so now take a look at these next several problems. You'll notice that something's different. You have this information right here. Okay, so now what we learned yesterday is that we can use reference angles when we're finding trig functions of an angle. So even though I might be, for example, finding the cosine of 210, I'm using the cosine of 30 to do that, okay? Now we have to think about several things. So when we see these directions here, that's telling us what quadrants we're in. Okay. So in between 90 and 180 tells us that we are going to be in the third quadrant somewhere. Okay. So watch what happens now when we do inverse cosine of 0.37. Second cosine 0.37, hit enter. Okay, we get theta equals 68 68.3 degrees. Now, that clearly is not between 90 degrees and 180 degrees. So we have to think about where the reference angle is going to be 68.3 degrees. So as we think about that, that means that if we draw this angle, it's going to be somewhere in that second quadrant like this, right? But our reference angle, not the angle itself, is 68.3. So really what we need to do now is find this angle. This is why reference angles are so important, guys. All right, so if we're in the second quadrant, we're just going to take 180 and we're going to subtract that 68.3 degrees. And that's going to give us our actual angle. And that's going to be theta equals 111.7. Now, you can check this by putting it in a calculator. Okay, so if I go inverse cosine, let's do that, of 111.7 on my calculator, okay, I got negative 0.369. If I do cosine of 68.3, I get positive the same thing. Now, what's the problem here? One of these is positive, one of these is negative. So if cosine theta equals 0.37 and theta's BN, so here we have a problem because remember from yesterday we discovered this pattern that all trig functions are positive here, sine is positive here, and cosine is positive here. So this actually is not possible. Okay, so we would need to change that to negative 0.37 if we wanted to make this work. Okay, so thinking through all of those things now, let's keep going and let's do another one. Okay, now I wouldn't give you one like that. It would be one that would work on a quiz or a test, but I wanted to show you guys that how we need to pay attention to those signs. All right, so let's look at our next one here. And let's go ahead and figure out what quadrant. We're going from 180 to 270. So that's going to be in quadrant 3. So as we draw this angle out, we know that it's got to be somewhere down here in quadrant 3, right? Okay. Now, I like to always use this as I go. A smart trig class. Notice tangent is positive in the third quadrant, so we're not going to have a problem like we had in number 3. All right, so all we have to do now is take inverse tangent, and this is where we're figuring out what angle, if we take the tangent of that angle, is going to give us 3.546. Okay, put that on your calculators. Second tangent, 3.546, and we get theta equals 74.25. We're rounding to the 10th here, so let's be consistent. We'll go to 0.3. All right, now remember, again, that is our reference angle. So that angle right here is this angle, 74.3 degrees. So we really want the angle on the third quadrant, so we need this whole angle there. So what we're going to do in this case is we're going to take 180, and we're going to add 74.3 degrees. And that's going to get that angle into that third quadrant. So there we go. Our final answer is 254.3 degrees. Again, now, if we double check this and we do tangent of 254.3, we get back to 3.557, which is close because we had that rounding in between, so it's a little bit different, but that's because we rounded it. Okay? All right, let's try out 2 more. Okay, this is good. It's helping you guys think about using reference angles. It's helping you think about finding those quadrants and what sign it is. So this is quadrant 2. All right. So now here's the question again. Can tangent be positive in quadrant 2? And our answer is a smart trig class. The only trig function that's positive quadrant 2 is sine. So this is an error. This is an issue. Let's make that a negative 1.7. Okay. So let's fix that. We're in quadrant 2. Let's go inverse tan of negative 1.7. And let's see what happens here. This might be interesting. Inverse tan negative 1.7. Okay, and we got theta equals negative 59.5. Interesting. So that gave us a negative angle, and that angle's in the fourth quadrant, but we can still use the reference angles. Remember, that's our reference angle when we make it positive. So we're going to be right here in the second quadrant. Our reference angle is going to be positive 59.5, and we want this angle here. So remember, we're going to take 180, and we're going to subtract 59.5, and that's going to get us our answer in the second quadrant. 180 minus 59.5. And we get 180, sorry, calculator issues, 59 minus 59.5, and we get 120.5 degrees for our final answer. All right, and let's do one more with cosine here. So from 270 to 360, that is in our fourth quadrant. So first question, can cosine be positive in the fourth quadrant? All trig functions are positive. A, smart trig class. Yes, cosine can be positive in the fourth quadrant, so we know it's going to be right here. Now when we do inverse cosine of that angle, we're going to get our reference angle. Go ahead, inverse second cosine, 0.09, and that gives us our reference angle is 84.8 degrees. So that's our reference angle right here. And notice mine's not to scale at all. That would be really close to our axis. But again, we're just doing this for the visual. So really, I need now this angle right here in the fourth quadrant. Okay. And that's going to give me, let's see, to get that, we now need to come all the way to 360 and subtract that reference angle. So we're going to do 360 minus 84.8. 360 minus 84.8, and that gives us 275.2 degrees. All right. Take a second, watch that again if you need to. Take a look at the homework. Try it a couple on your own. All right, let's continue with our next several problems here. Okay, all we're asking is to determine the quadrants in which the values would lie. So this is simply saying, where is cosine greater than 0? So where is cosine positive? So if you guys just do this once, this will be pretty quick for all of these problems. A smart trig glass. So cosine is positive here and here. So that's quadrant 1. 1 and 4. And we usually use Roman numerals. You don't have to. You can write them as regular numbers if you want. All right, this is saying now where is sine less than 0? So where is sine negative? A, all sine positive. So that would be in quadrants. Should I label them here for you guys too? Numbers 1, 2, 3, and 4. So sine would be negative in quadrant 3 and 4. All right. Where's tan less than 0? So where's tan negative? And I can see they're all positive in 1. Tan's positive in 3. So tan's going to be negative in quadrants 2 and 4. What do you guys like better, Roman numerals or regular numbers? It's up to you. You'll see them with Roman numerals a lot. Again, regular numbers are fine. Where's cosine less than 0? So where's cosine negative? And we can see up here again, cosine is positive in 1, is positive in 4. So it is negative in quadrants 2 and 3. All right, that's all those questions are asking. But that's incredibly important as we start using these inverse trig functions, because we have to figure out what quadrants our angles are going to be in and use our reference angles. All right, let's keep going. All right, now I want you to notice a couple things here. So first of all, this is very, very important. It tells us two things. It tells us first, our answer needs to be in radians. Answer in degrees will not be correct. Okay? It also tells us to consider all 4 quadrants. Not just one quadrant like we saw before. Before I was telling you I want it in this quadrant. Now I'm saying you need to think about all 4 quadrants. Okay? So this is where we are not going to use a calculator. Okay? Now I realize you guys are sitting at home. You have no one to enforce that, whether you're going to use a calculator or not. Practice without a calculator. This will come back to bite you in pre-calc if you don't practice now. You will not have a calculator for this in pre-calc. You will not have a calculator for this in AP Calc. Make sure you guys can do these. So practice without a calculator now. All right, so check it out. There's some things that hopefully look very familiar to you guys. And here's what I recommend. We have root 2, 2. We have 1, 2. Okay. What I recommend is you guys on a separate sheet of paper draw your special right triangles. Okay, I'll draw it for everyone, but if you guys have them to refer to, it's really easy to match it up. So I'm going to start with 45, 45, 90, and I know that in a 45, 45, 90, my hypotenuse is 2, and my legs are both root 2. And then let's get our 30, 60, 90 here, and I know that in a 30, 60, 90, my side opposite 30 is 1, my hypotenuse is 2, and 60, opposite 60 is root 3. All right, anytime you see root 2, that's going to be a 45, 45, 90. Anytime you see a 1, 2, root 3, that's going to be a 30, 60, 90. So really what you guys have to think about is, first of all, this is positive. So in which quadrants is cosine positive? Let's write that down. Cos is positive in, not is, in 1 and 4. So we're going to use the reference angles now, and what we're going to basically say is, for which angle does cosine equal root 2 over 2? So for which angle is the adjacent side root 2 and the hypotenuse 2? And we can see that right here. Here's 45, adjacent side root 2, hypotenuse 2. So if it's in quadrant 1, then that's our first one. But now we need to use that reference angle to get it into quadrant 4. So if you want to draw a picture, you can draw that picture. There's our reference angle 45 in quadrant 4. To get there, we're going to go all the way around here, and we're going to do 360 minus 45, and that's 315 in quadrant 4. Okay, so there's our 2 solutions. Now, what's the problem here? Hopefully you guys are looking back. Look at the directions. What do I need to do still? I'm not quite done. I got 2 angles. They're both between 0 and 2 pi. They're both in positive cosine quadrants. A smart trig class, wherever you want to write that to label. Okay. The problem is that they are not in radians. So you guys decide at what point do you want to convert these to radians. Okay. I know that 45 is pi over 4. 180 divided by 4 is 45. Okay, so if I go all the way around my circle to 2 pi, that's 8 pi over 4 minus pi over 4 equals 7 pi over 4. You guys can have that unit circle that you filled in with all those measurements. That is what we need to have for our final answer. Okay. Otherwise, you can just convert 45 and 315 to radians and then be done. So there's a lot of things to think about here. All right. Let's keep going. Let's look at our next one. Okay. So first here, sine is negative. And which quadrants is sine negative? A, smart, trig, class. We can see we need quadrants 3 and 4. Okay. So when we look at this, sine is opposite over hypotenuse. So which angle is opposite side of 1 is 30, hypotenuse is 2. All right, so our reference angle equals 30 degrees. But our answer is not 30 because that would put us in quadrant 1 and make sine positive. So we now need to be in quadrants 3 here and 4 here to get it to be negative. All right, so if that reference angle is 30, that reference angle is 30. This one, we're going to go to 180. We're going to add 30. Maybe you want to think about this in radians right now. 30 is pi over 6. So really what we're doing is 6 pi over 6, or 1 pi, plus pi over 6, which gives us 7 pi over 6. So there's our answer in the third quadrant. Okay, I'm going to go all the way around to 2 pi. So 2 pi and 6 would be 12 pi over 6. And now we have to subtract that reference angle to get us back into that fourth quadrant. So 12 minus 1 is 11 pi over 6. And there's our two answers in radians. Again, a lot of things to think about, all right? Next one, where is cotangent theta undefined? All right, so this is a reciprocal function, so I got to think about it like this. All right, if we draw this unit circle, and this doesn't matter if you use 1 for these points or 2 for these points for your coordinates, whatever you guys want to use, but write your coordinates out there. So if we use 1, 1 comma 0, 0 comma 1, negative 1 comma 0, 0 comma negative 1. All right. Now, to get something that's undefined, okay, let's write out what we know. So tan theta is opposite over adjacent. So that means cotan, not cosine, cotan theta equals adjacent over opposite. And remember what we figured out yesterday is that our adjacent side is represented by our x coordinates, and our opposite side is represented by our y coordinate. So we're looking at this and we're saying, okay, where is this going to be undefined? It's going to be undefined when the y coordinates equals 0. So look at all our points where the y coordinate equals 0. X equals 0, x equals 0, y equals 0, y equals 0. Okay, so now look, I have 0 inclusive, not inclusive to 2 pi. So our answer is going to be theta equals, and I'll use a solution set here for this. So 0 is our first one, and then pi is going to be our second one. Okay. You guys might need to go back and practice these some more, work on that homework number 2 some more. Okay, that should help you guys a little bit as you're thinking about those quadrantal angles. All right, I'm not going to do all these. I'm just going to do a few more for you guys and then let you check them out on your own. All right, so I see a root 3 here. So again, you guys should have your special right triangles right in front of you. So root 3 tells me I'm going to be using a 30, 60, 90. So I'm going to fill out that 30, 60, 90. And this is what I want. Sine is positive. So in which quadrants is sine positive? And that's going to be in quadrant 1 and in quadrant 2. And sine, I like to match this up, is opposite over hypotenuse. So which angle is opposite root 3? That's going to be 60. So that means that this is 60 and this is 60. Okay, now again, you guys can do your work in degrees and then switch to radians, or we can start thinking about it as radians right now. So 60 as radians is going to be pi over 3. Okay. Now, if I'm going to work my way back to this one, I'm going to go to pi, which is just getting that common denominator. 1 pi is 3 over 3 pi. And I'm going to subtract that pi, 1 pi over 3. So it's 3 pi over 3 minus 1 pi over 3. And that gives us 2 pi over 3. So there we are, first quadrants and second quadrants. All right. Let's see. Let's do 16. All right, so we have sine theta equals 0. So when we see -1, we see 0. Think about our quadrantal angles. All right. And again, write those coordinates in there. I used 2 in the notes yesterday. You can use 2, you can use 1. It really doesn't matter. Okay. 1, 0, 0, 1, -1, 0, and 0, -1. All right, so sine theta equals opposite over hypotenuse, which remember was y over, in this case, our radius is 1. So here we just want to know where is the y coordinate equal to 0 to give us that sine equals 0. So our y coordinate is 0 here. So that's at 0. And here, pi. All right, I'm going to do one more for you guys. Let's do number 18. All right, so I see a root 3 there. So again, I know this is going to be my 30, 60, 90. Okay, I see that tan is negative. So where is tan negative? A smart trig class. So tan's going to be negative here in quadrant 2. Tan's going to be negative here in quadrant 4. All right, so if we think about this now, tan is, so think about that over 1, opposite over adjacent. So our opposite side is root 3, and let me label this guy for us too. Our opposite side is root 3, then that's going to be 60. So that's our reference angle again. Okay. Again, you can do your work in degrees or you can switch to radians here. All right, our reference angle is 60 degrees. In radians, that's pi over 3. Okay, so that means this is pi over 3. So 3 pi over 3 minus 1 pi over 3 gives us 2 pi over 3. And I'm going to go all the way around to here. And that's going to give me 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. Look at that circle to help you guys out with this. All right. I'll let you try these out on your own. I will post the rest of these completed to the Google Drive. Please let me know if you have questions, okay? Homework is attached, so you guys can start working on the homework too. You're going to have Friday and Monday to check your solutions, get caught up with all your videos, review your notes. Monday, I'll give you guys the review for the test. Tuesday, I'll do a little video, do a few problems to review. Wednesday, we'll host a Google Meet to answer questions. Thursday will be the big day. All right, hope you guys are all doing well. I miss you, and talk to you soon.